All right, let's get right into it. We all have this vision of an AI that can learn and grow with us, kind of like a true digital partner. But there's this huge fundamental problem that's been holding that whole idea back.
And that brings us to the central challenge, right? How in the world do you create a system that can pile up knowledge over time, just like a person does, without basically wiping its own memory every time it learns something new? Today, we're going to look at a really fascinating solution that might just crack the code.
So this problem, it's got a pretty dramatic name, catastrophic forgetting. And let me tell you, it is exactly as bad as it sounds. It's basically AI amnesia. You could teach a model to be a brilliant poet, and in the process, it might completely forget how to do simple math. It's a massive, massive roadblock.
Now here's the kicker. The very way we usually teach an AI new skills, it's a process called supervised fine-tuning, or SFT for short, well, that's what's actually causing the problem. It's like we're trying to build this incredible tower of knowledge, but every time we add a new brick on top, the foundation just crumbles away. Okay, so take a look at this graph. It shows you the problem perfectly. See that red line? That's the standard method, SFT. As the model moves to the right, meaning it's getting better at a new skill, notice how the line just plummets downwards. It's getting dumber on the things it already knew. It's a total zero-sum game.
So that's the million-dollar question, isn't it? How do you add new knowledge without throwing the old stuff out? For a long time, this has been a real head-scratcher for researchers. But a new approach has a surprisingly, elegant answer.
It's called self-distillation fine-tuning, or SDFT. And the core idea is, honestly, pretty beautiful. Instead of just force-feeding the AI new information, you get the model to be both a student and its very own, slightly wiser teacher.
So here's how that works. For any problem you give it, the model wears two hats. The student hat gets just the question, cold. It has to figure it out on its own. But at the exact same time, the teacher hat gets the question plus a little cheat sheet, an expert example of how to solve it.
And this diagram shows where the magic happens. The teacher, with its little hint, doesn't just give the final answer. No, it shows the student the thought process, the steps to get there. It's not about cheating. It's about giving the student's own internal logic a gentle nudge in the right direction.
This whole thing creates this awesome little feedback loop. The student tries, the teacher offers some coaching, and the student adjusts its thinking to match. And it all happens in real time, what the researchers call on-policy learning. It means the student is learning from its mistakes as it makes them, not from some dusty old textbook.
Okay, so the idea is clever, right? It sounds great on paper, but the real question is, does this whole student-teacher thing actually work? Does it stop catastrophic forgetting? Well, the results, they're pretty incredible. Let's jump back to that first graph we saw. Remember that red line that just took a nosedive? Okay, now look at the blue line. That's SDFT. It's a perfectly straight horizontal line. The model gets way better at the new skill, but its performance on the old tasks doesn't drop one bit. It's learning without forgetting.
That's pretty cool, but what about a real stress test? The ultimate challenge. Can a model learn not one, not two, but three different skills, one after another, without the whole thing just falling apart?
And the answer is a resounding yes. Look at this. With SDFT, first it learns to use tools. Check. Then it learns science Q&A, and it's still great at using tools. Then it learns medical knowledge, and it still remembers the other two skills perfectly. It's actually building on itself. But now, look at the old method. It's a totally different story. The moment it starts learning that second skill, bam! The first skill is just gone, totally wiped. Then when it learns the third skill, the second one disappears. It's like a leaky bucket. You pour new knowledge in, and the old stuff just drains right out.
And what's really, really cool is that this isn't just for learning skills. This also works for teaching the AI new, hard facts about the world, updating its knowledge without breaking everything.
So to test this, the researchers basically gave the model a history book from the future about fictional events in 2025. And the SDFT model didn't just learn the facts more accurately. It was way, way better at actually using those facts to answer totally new questions it had never seen before.
Yeah, that 98% right there, that's the number that should really make you sit up and pay attention. It's called out-of-distribution accuracy, which is a fancy way of saying the AI isn't just parroting back facts, it actually understands. It can connect the dots. That's a sign of much, much deeper learning.
So let's zoom out. What does this all mean? Well,
It means we can start looking at a future where AI isn't some static thing that gets old and outdated. We're talking about systems that are alive, that can adapt and improve after they're out in the world. Imagine a personal assistant that actually learns from you every single day. We're moving from just having tools to having real collaborators.
And hey, you don't have to take my word for it. The researchers themselves put it perfectly. They say this method makes true continual learning possible, letting a model get better at new things without forgetting what it can already do.
And so that leaves us with one last big thought. What happens when our technology stops being just a static tool and starts being a learning partner? One that can grow and adapt with us every single day. The possibilities? Well, they're really exciting to think about.